In this lesson, we will learn about DNS Basic Concepts. First of all, we will learn about Recursive Query, then Authoritative DNS Servers, and Delegation. After that, we will learn about Iterative Query, Recursive DNS Server, and Domain Namespace. Finally, we sum up the lesson with the keynotes. Recursive query happens when a DNS client sends a single query to its local DNS server and expects the DNS server to answer with a result or an error message. The DNS client will not send any additional queries to other DNS servers to find the answer. This type query is called recursive query. An authoritative DNS server of a domain is the DNS server where the domain and its DNS records are created and updated. The authoritative DNS server answers queries for its records immediately without querying any other DNS servers. It is possible to configure multiple authoritative DNS servers for the same domain, but these servers must be in sync with each other. As you can see, our PVDC01 is the authoritative DNS server of the domain hq.itlifeskills.local because it is hosting the domain and its DNS records. Therefore, our PVDC01 will answer the queries for any records of the domain hq.itlifeskills.local without querying any other DNS servers. We can have PVDC01 as the authoritative DNS server for the domain hq.itlifeskills.local, but the DNS records must be in sync between our PVDC01 and our PVDC01. Let's take a closer look at recursive query and response in this example. First of all, this client laptop sent a recursive DNS query to our PVDC01 and asking what is the IP address of pvdc01.hq.itlifeskills.local. The DNS server, our PVDC01, checks in its forward lookup zone and found the domain name hq.itlifeskills.local, and it found the records for PVDC01, so it knows that it is the authoritative DNS server of the domain hq.itlifeskills.local, and it responds to the query with the answer. The IP address of pvdc01.hq.itlifeskills.local is 10.20.0.10. The next concept is delegation. As you may know, a DNS server can provide the service for both parent and child domains, or it can have delegation, which configures additional DNS servers to be the authoritative DNS servers for the child domains. So in this DNS server, GPVDC01, we see that it hosts the parent domain itlifeskills.local, and it configures with the delegation for the child domain hq.itlifeskills.local. In the delegation, it configures two additional DNS servers, HPVDC01 and OutPVDC01, as the authoritative DNS servers for the child domain. As you can see, delegation contains the pointers to the authoritative name servers for the child domains, and delegation is only configured for contiguous namespace. Let's learn about Iterative Query. As you may know, an Iterative Query allows a DNS client to send sequential queries to a list of DNS servers in which the former DNS server will provide the IP address of the latter DNS server. And here is the process. When a DNS client sends an iterative query to a DNS server that does not own the records, instead of answering with an error, the DNS server provides a referral to the next DNS server that might have the answer. The client then queries the next DNS server, and the process continues until the client gets to the authoritative DNS server to get the IP address. Let's get into the details of iterative queries in this example. First of all, the IT Life Skills PC send an iterative query to the root DNS server to ask for the IP address of training.itlifeskills.com. Since the root DNS server does not own the records, it provides the IP address of toplevel.com DNS server to the PC. The PC again sends an iterative query to toplevel.com DNS server, and again the toplevel.com DNS server does not own the records, so it provides the IP address of the authoritative DNS server of the itlifeskills.com domain to the PC. The PC again sends an iterative query to the authoritative DNS server of itlifeskills.com domain, and this time it gets the IP address of the training.itlifeskills.com as 15.97.142.173. The next concept is Recursive DNS Server. A recursive DNS server is the DNS server that does not own the records in the query, but it can perform iterative queries on behalf of the DNS client to find the answer, then return the IP address to the client. Or it can act as a DNS client by sending a recursive query to another DNS server to get the IP address, then answer to its client. Let's learn more about Recursive DNS Server in this example. First of all, the IT Life Skills PC sends a recursive query to the DNS server GPVDC01 to ask for the IP address of our pc01.hq.itlifeskills.local. The DNS server GPVDC01 checks in its forward lookup zones and finds the domain itlifeskills.local, and it finds the delegation for the child domain hq.itlifeskills.local, and it finds the records for the name server rpvdc01. So it sends a recursive query to the name server rpvdc01 to ask for the IP address of rpc01.hq.itlifeskills.local. Since the rpvdc01 is an authoritative DNS server of the hq.itlifeskills.local, So it answers the GPVDC01 with the IP address of our pc01.hq.itliveskills.local as 10.10.0.100, and the GPVDC01 answer the IT Life Skills PC with the IP address of our pvdc01.hq.itliveskills.local as 10.10.0.100. Now let's learn about domain namespace. As you may know, it starts with the root domain, then the top level domain, and the second level domain, and can be the third and the fourth domains. So in this DNS records, we see that this is the root domain, then the top level .com domain, and the second level domain itlifeskills.com, and this is the DNS host name or fully qualified DNS name FQDN. This is the end of this lesson. Let's read the keynotes.